So in this video, I want to do a few examples of Cauchy's integral formula in its derivative counterpart. So I want to evaluate, let's start with sine of z over z squared dz. And we're going to integrate over some circle centered at the origin of whatever radius, I don't care, say 4. So we're going to evaluate this integral. And what we're going to do is we're going to think of this as the integral of f of z over z minus 0 squared. Here our f of z is sine of z. Our w is, of course, just the complex number 0. And then what we need to do is we need to notice that, the kth derivative, I just always have to write this out every time. The kth derivative is k factorial over 2 pi I integral of f of z over z minus w to the k plus 1 power. And so here our k is 1, because our k plus 1 is 2. And so we're talking about the first derivative. So this is going to be equal to 2 pi I over 1 factorial, which is just 1. So we don't really even need to write that, times the first derivative at 0. And so the derivative of sine is cosine. Cosine of 0 is 1. So this is just going to be equal to 2 pi I times 1. And that is it. Okay, so that's all we need to do for that one. Okay. Next, let's evaluate. Okay, so next let's evaluate the integral of 1 over z times z minus 5 squared dz, where we're going to integrate over some circles centered at 5 of radius 2. Okay, and so this is a circle centered at 5 of radius 2. Notice that this 1 over z is actually holomorphic in that region, because 1 over z is holomorphic everywhere except at the origin. And the origin is not in this inside the circle, so everything's fine. And what that means is that we can just apply the same formula. Here our f of z is going to be 1 over z. Our w is 5. And this is going to be equal to, so our integral of 1 over z times z minus 5 squared dz is going to be equal to 2 pi I over 1 factorial times f prime of 5. And so if we take the derivative of this function, we'll get negative 1 over z squared. And so it's going to be 2 pi I over negative 25, or negative 2 pi I over 25. Okay, and that's really all we have to do there. And then one more. Let's evaluate the integral of e to the z over z cubed dz, where this is just going to be over the circle centered at 0 over radius 1. All of these circles, by the way, are positively oriented. So we're going to evaluate this integral, e to the z over z cubed. And let's see what's going to happen here. We're going to end up with, let's see. So our function f of z is e to the z. Our w is 0 again. And this is now to the third power in the denominator. So that means that it's going to be the second derivative. So this integral is going to be equal to 2 pi I over 2 factorial, which is 2, times the second derivative of f at 0. But the second derivative of e to the z is just e to the z, because the first derivative is e to the z, of course. And so everything, when we plug everything in, we get pi I, and that's the end of the story. Okay, so pi I is the integral here.